connecting your device to an information technology platform is challenging due to the lack of a common framework of communication between the two domains. However, there are a number of technologies that are being developed to enable you to easily transmit information from one domain to the other. One such technology is Node-RED, and in this video I'm going to show you how to use Node-RED to connect an industrial controller to a database service running either on the cloud or on premise. So let's get started. Hi, I'm Kutsaimandi Teresa, and I'll be your host as I show you how to use Node-RED to collect data from an industrial controller and send it to a database service on which analytics could then go on to be performed on that data. I have experienced firsthand the trouble of having to develop custom drivers to access data from a Modbus device or serial port with the goal of sending that data across to the cloud. It's actually time spent on less value-adding activities. So a visual tool like Node-RED makes it extremely easy to connect physical assets to digital services, as you will see shortly. So with the hope of helping you overcome the same challenge, in this video I'm going to demonstrate to you how to collect data from a programmable automation controller that talks Modbus and send that data to a SQL Server database. Okay, so what I have here is a Snappack R1 programmable automation controller from Opto 22. This is a rack mountable controller, and it's typical of a device you'd find in a factory controlling and collecting process data. And like most devices that are currently being used for this purpose, its primary form of communication is based on point-to-point protocols like Modbus TCP, for example. And because of that, there is a challenge in sending that data across the internet, right? Now, as you can see here, I've got some I/O modules on the rack, and on this analog to digital module I have got this potentiometer connected. So what we're going to do is we'll read the value of this potentiometer, right, and write it to a memory location that is Modbus address mapping, and then periodically send it to a SQL Server database, all using Node-RED. Okay, so now I've got this control software running my logic. So this is where I'm continuously reading the potentiometer value and writing the value to a scratchpad memory location that is a Modbus mapped address. So if I pull up this port tag, right, and if I turn up my potentiometer, you can see it changing the value there, right? And then now using this utility software, we can see our value here on the scratchpad memory location. That's our value there, and then we're then able to go on and copy the address and use the Modbus calculator to give us the register address and the unit ID. Now bear in mind that this process differs according to devices, but in most cases it's a straightforward process, and you can find the Modbus mapping information in device datasheets. Okay, so we won't be covering the whole process of installing Node-RED on your system, but basically what you do is you install first Node.js at this address www.nodejs.org, and then after that you pull up your command prompt, you type in this instruction that is to install your Node-RED, and when that is done you install your Node-RED Modbus node using this instruction here, and then using this command here you install your MS SQL node. And then when all of that is installed, you can start your Node-RED using this command here. And then once your Node-RED is running, you can access it at localhost port 1880, and then when you type that in, you'll get this interface that we're looking at right now. Okay, so now we're ready to build our Node-RED flow to collect data from our controller and send it to a SQL Server database in the cloud. Right, so basically to my left here, you see there is these are the nodes, and then to the right of the window here there is the debug window for debugging your flow. Right, so all the nodes that we installed are here. As you can see, there is the MS SQL node, and then there is the Modbus node. So I'll begin by putting here this inject. It's an input node, so here we specify what type of input are we going to be injecting into the flow. So in this case it will be a string, right? And then we'll only initiate once we click on the input node, right? And then I'll also need a function to build our Modbus message, right? And then I'll also need this Modbus getter, right? So this is where we put our Modbus device IP and the port number, right? So if you go down here on the info window here, and then we just copy this structure, and then we put it onto our function block. Right, so this is our function code. So in this case, since we're reading a holding register, our function code is 3, right? And the unit ID it's 110, if you still remember from our utility to calculate the Modbus address. And the address of our potentiometer value is 4096, and then it's 2 bytes that we're reading. And then we can join these two, and then the next step is to configure our Modbus client. So my controller IP address is 10.0.0.87, and the Modbus port number is 502, right? And then I'll connect these two, and then we'll also need the Modbus response to debug our solution, right? And then we can deploy, and then when we click on inject, we can see there is data on our response there. And then maybe we need to put a debug output, right? You can see we're getting an array of 2 numbers. So this data is meaningless, really. So now we need to convert it to something that is more intelligible, something that can be understood. So to do that, we're going to need a function to convert this into a float number. So I've already copied this function. So basically this function, what is happening here is that it's converting this 2-byte array into a float number. We deploy, and then we debug. There we get our 61. Okay, so now what we need to do is to send our value to the database. So we need to go and create our database first. So what I've done is I've already gone ahead and created a database on my Azure portal. It's the Node-RED DB, right? So I can pull up my SQL Server Management Studio and connect to that database. So that's the server name on the Azure. and then there you can see there is our Node-RED DB. Right, and then our table name, I've also created a table. And then we can see we've got potentiometer value, and there's nothing on our table there. Right, so now we go back to our Node-RED, and then we pull up our MS SQL node. So now what we need to do is we take the output of this function, which is our float value, right, and connect it to our SQL Server node, right. So already it's pre-configured with my credentials, and then our database is Node-RED DB, and then we give it a name, and then this is the server address, right. And then here we can say insert, right. And then I've got I'm gonna paste the script that I've already typed for you. So basically what we're doing here, this is a query. We're inserting the payload into this table on this column, right. Deploy, and then we inject. Now if we go back to our SQL Server database, you can see there is our value here, and then if I turn down the port a bit, and then we come back here, we insert, execute, you see there is our value there. And for practical purposes, we can even specify the intervals to say we want to log the value of the potentiometer after every, say, 5 seconds. Right. So after every 5 seconds, we should see a new value logged here. I turn it up. So you can see we're getting values after every 5 seconds. As you have just seen, I've managed to capture what could be sensor data and transmit it across domains and store it with a very little code written. And well, the most powerful thing is that this flow that we've just built, we can actually share it with someone, and then they could import that onto their Node-RED solution, so they wouldn't have to write any code at all. And well, so it's quite a compelling solution, and there's most likely a node for whatever you want to achieve. And if it is not there, there is one that is close to it, and you can edit it and use it as their open source. Okay, so that brings us to the end of this video. Thank you for watching, and I'd love to hear from you in the comment section below. If you found this video informative, please share it with your connections. Also subscribe to this channel for more videos, and let us also connect on social media. Bye.